Welcome to Best Practice Lubricant Storage and Handling Part 2. I'm Jared Pottiger, Education Services Manager for Deskcase. In Part 1 of this series, we talked about the importance of precision fluid handling, lubricant receiving methods, also storage solutions, as well as lubricant dispensing. In today's segment, we're going to talk about lubricant transfer containers, the proper use of funnels, direct application using portable filtration units, and also maintaining the cleanliness of in-service lubricants. Let's begin with oil transfer containers. A good quality oil transfer container, or oil can if you like, should be made of plastic. Metal containers are inherently dirty, they promote condensation, and some of the coatings on metal containers can even react with certain additives in the lubricants. They should be marked for product type, preferably color-coded, but also labeled with the specific product. This is not only a good way to avoid cross-contamination of lubricants, this is also an OSHA requirement. The container should certainly be sealable. This is probably the most important attribute of a good quality transfer container. We need to be able to seal them to prevent atmospheric ingression of contaminants. They should also be cleaned periodically. Even the best designed oil transfer container will probably not stay clean forever, so we do need to clean them from time to time. They should also be filled with pre-filtered oil. You might think this goes without saying, but you'd be surprised how many people will pay good money for a high-quality transfer container and then fill it with oil directly from a drum that's already heavily contaminated, which really negates the value of a good quality transfer container. Finally, they should be stored in a reasonable manner. They should be stored preferably in a locker, rather than being stored out in the plant, under a machine, in the back of a cart, or somewhere else where they're going to collect a lot of contamination. These things get oily, and that tends to pick up dirt. If there's dirt on the outside of the container, it's probably going to end up on the inside of the container. So let's look at an example of how not to store a good lubricant transfer container. This picture actually illustrates three different problems. One, of course, is the storage location. We don't want to store top-up containers out in the plant next to machines where they'll get dirty. But we also don't want to modify the transfer container and eliminate the value of it by chopping the nozzle off of it. A lot of times we see this, people remove the nozzle from the spout so that the oil will flow more easily, but in doing this they eliminate the ability to seal it, which of course was the most important part of the container. Now, the third problem that this illustrates is a lack of education. A lot of times we buy high quality tools for lubrication but don't bother to educate the technicians on what the end result should be. In this case, we use a sealed top-up container so we can deliver clean oil. The person who modified this container probably didn't realize that they were ruining it by chopping the nozzle off of it. So we need to make sure that we educate folks not only on what they should be doing, but why they should be doing it and what the desired end result is. Funnels don't really belong in a precision lubricant handling system. Funnels are necessary when we don't have good application methods available to us. When we use good quality transfer containers that have hand pumps or have nozzles that are designed to deliver oil through a small opening, we really don't need funnels, especially if we use quick connect fittings in conjunction with the machines and the transfer containers. That really eliminates a lot of ingression that takes place when we're applying oil. But in some cases we may have to use funnels because we simply have no other way to effectively get the oil into the machine. So if we must use funnels, we definitely shouldn't use funnels like the one we see here. We should use plastic or disposable funnels, preferably sealed in a plastic container, dedicated to specific product types. Basically, we should do whatever we can do to eliminate funnels in most of our applications, but where we do need to use funnels, we just need to take whatever steps we can to minimize the amount of contamination that we're going to be adding. Getting clean oil into a machine can actually be pretty challenging. It's not as easy as simply filtering new oil. That's the first step, but then we have to make sure that that oil is clean when it goes in the machine. So if we filter the oil but then we dispense it through a spigot into a top-up container, and then we transport the top-up container across the plant, and then we pour it through a funnel or directly into the opening, on a reservoir, there's a lot of opportunity there for further contamination. We can recontaminate that oil even if we filtered it beforehand. The best way to eliminate all of these opportunities is to simply filter the oil as it is applied to the machine. Now, we can't do this for just any machine, but for those that have more than, say, 2 or 3 gallons of oil, we can use our portable filtration equipment like a filter cart, assuming we have fittings on the machine and fittings on the storage container. We can couple up that filter cart and filter the oil as it's pumped directly into the machine. Not only does this achieve our primary goal of getting clean oil into the machine, there's also some other benefits as well. This takes a lot less time than most conventional methods for oil transfer, so it's much more efficient. We can also use the filter cart to remove the old oil if we're doing an oil change. We can simply bypass the filters by using the isolation valves and use it as a transfer pump to evacuate the old oil and transfer it to a waste oil container. Not only does it remove the oil more quickly, it removes it more thoroughly. It's also safer and there's less likelihood of spills, which is also an environmental concern. So when the volume of oil being transferred is sufficient, this is definitely the preferred way to transfer oil. Now, this is an example of using portable filtration equipment to do an oil change. In this case, they take the filter cart and bypass the filters and use the filter cart to transfer the waste oil from the gearbox to the waste oil container. Then they reconfigure the hoses so that they can deliver the new oil to the gearbox, once again engaging the filters so that we're filtering the oil in. But then they take it a step further and they reconfigure again so that they can circulate the oil in the gearbox. Now, this is going to do an even better job of making sure that we have clean oil in the system. Now, if you look at the pictures on the screen, you'll see 3 different patch tests. So these were samples of oil that were filtered through a fine patch and then had pictures taken of them. And in the upper left-hand corner, we have a patch test from the new oil. This was the oil from the drum that was to be added to the system. And as you can see, it's pretty dirty. The one to the right of that is the unfiltered in-service oil. So this is the waste oil that was being discarded. And as you can see, this oil that's being thrown away is much cleaner than the new oil taken from the drum. And then finally, in the other patch test, we have the new oil after it was filtered. So again, it was filtered when it went in, and then it was circulated in the system. Now, if we look at a magnified image of those patch tests, you'll see this is the new oil. So in a gearbox like this, we're concerned with very small particles, as they're the ones that cause most of the harm. So we're concerned with 1, 2, 3, 4, 10 micron particles. In this case, we can see quite a few particles that are larger than 100 microns. So if we have particles greater than 100 microns, you can imagine how many millions of particles that are down there in that range less than 10 microns that are going to be present in this oil. Now, this is a magnified image of the new oil patch test. And as you can see, there are no visible particles in the oil at 100 times magnification. Now, if you realize that the number one factor that's going to affect the service life of that gearbox is how many particles are in the oil, this really illustrates the value of using precision handling and filtering oil before it goes in the machine. So using portable filtration equipment to transfer fluid is not only the better way in terms of contamination control, it's also the easiest way. But in order for that statement to be true, we have to modify the machines. Most reservoirs don't come fitted with quick connect fittings, so that's a modification that we're going to have to make. Now, Deskcase offers a number of different adapter kits that are designed not only to allow us to transfer fluid this way, but also to protect the cleanliness of the oil in service. So we have adapter kits for oil drums that are designed for circulating the oil in the system, also to allow us to remove the oil using portable filtration equipment. And they also come with a breather to prevent ingression of moisture and particle contamination into the drum. We have reservoir adapters that are designed to work with hydraulic reservoirs and circulating system reservoirs that directly replace the breather caps that we typically see on these types of systems. Those can also come with a sample valve that allows us to easily take samples from the system. We have the small case adapter or gearbox adapter, which has a quick connect for filling. Also comes with a breather to prevent moisture and particles from entering the system. And then the tote adapter kit, which provides the same features for a tote. So however you go about this, and if you're going to use portable filtration equipment to transfer oil, you're going to have to put the right types of fittings on the machines. Otherwise, it's simply not practical to use them. Now, another key element of oil application is preventing cross-contamination. And this is most easily achieved by a good identification system. So we certainly want to tag all of our oil transfer containers. We also want to tag our filtration equipment and identify that as being for use with a specific type of product. But it's also essential for precision lubrication that we apply an identification systems to the lube points themselves. So basically, any tool or any point on the machine that is associated with a certain type of lubricant, we should have a tag that identifies that. So we know which oil comes out of which spigot on the dispensing station, goes into which top-up container, and goes into which lube point in the plant. Now there's a number of different ways to do this. There are a number of different options that are commercially available, but however you go about doing this, you need to come up with a system that is not just labels with names on it, but something that's really conspicuous, something that uses colors, it uses shapes, and uses a code to identify which type of lubricant. Now, if you notice in the example here, there's no actual product name on these tags. It's actually a generic product description. So in the example in the lower left here, we have an AW68 PAO. So that tells me that this is an ISO 68 lubricating oil that has a PAO or SHC type synthetic base oil, and it's an anti-wear additive system, or it's an anti-wear type lubricant. The value of using a generic system like this is that when our lubricant provider changes the names of products, or if we had to switch from one supplier to another, we could keep the same tagging system in place without going out and replacing all of those lubricant tags. So this is a very crucial part of a good lubricant storage, handling, and application system. Now, once we've added clean oil to the machines, we also need to make sure that it stays clean inside the system. Now, the good news is this is fairly easy to do with most machines, because most of the contamination in the average machine comes from just two sources. It comes from the new oil that we apply, and it comes from the air that the machine breathes. Now, we've already talked about how to deal with the cleanliness of the new oil. So eliminating the contamination in the air the system breathes is very simple, and there's a number of ways we can do this. Desiccant breathers are an excellent choice for eliminating not only the particles that come in with the air, but also the moisture. So a desiccant breather has a 3-micron mechanical filter that removes particles, but it also has a silica gel stage that lowers the relative humidity of the air that comes in to about 25%, preventing condensation inside the system. So desiccant breathers and hybrid breathers are an excellent way to maintain oil cleanliness in service, assuming we got clean oil in there in the first place. There are other ways to do this as well. We could use expansion chambers. We could purge the system with conditioned air or with nitrogen or with an oil mist system. So basically, if we put pressure inside the system, then dirty, humid air on the outside can't get in because it's always breathing out. Now, these pictures are examples of how easy it is to retrofit existing equipment with a good quality breather. Most machines already have some type of breather port, and they'll either have a breather cap, or they'll have a plug with a hole in it, or a number of different types of breathing devices. But in most cases, those can be very easily removed, adapted, and then fitted with a high-quality desiccant breather. Now, we've talked about using portable filtration equipment to transfer new lubricants, but when filter carts first came onto the scene, that wasn't really the intention. They were originally designed for decontamination of systems, and this is still a very valid use, although we found there are other uses as well. But we still do use portable filtration equipment for decontaminating in-service oils. This is most effective when we have a system that has good contamination exclusion methods so that we can decontaminate only when necessary. If we have machines that require frequent decontamination using portable filtration equipment, a better choice might be to go to continuous filtration. So rather than use a filter cart and hook it up as necessary, or when oil analysis indicates that the oil has gotten dirty, we can simply install a kidney loop filtration system, and then we get the benefit of having continuously clean oil, because it's not that helpful to decontaminate oil if it's going to get dirty again very quickly. We simply have clean oil for a short time and then it gets dirty again. So this is really a decision that needs to be made. You need to evaluate those systems for which you use portable filtration equipment to see if it wouldn't be more cost effective to simply install a permanent kidney loop system. Now again, in order to use portable filtration equipment, a lot of times we have to make modifications to the equipment. We also need to make modifications sometimes for doing visual inspections, like adding a sight glass so that we can check the oil level, adding a sample valve so we can take a good oil sample, and of course adding quick connect fittings so we can use our filter cart. But what I would suggest is that you create a preferred configuration or a plan to modify all of the different types of machines in your plant. One of the things you find out when you do this is that even if you have hundreds of different machines, it doesn't take hundreds of different modification plans. You can simply come up with 2 or 3 different modification plans for gearboxes, maybe 1 or 2 for pumps. Some systems, larger systems like compressors and hydraulics, you may have, those might be customized for each machine. But in general, 10 to 20 modification plans is all you should need to cover all of the equipment in your plant. So I would suggest creating, again, a preferred configuration, including diagrams that show which components go where and simple instructions for how to make those modifications. Now it can take years to actually modify all of the machines in the plant, but the first step is to identify what that desired outcome is. So we need to have documents that show the proper configuration for each machine, and we can look at a few examples of those. This is one example of a gearbox modification. In this case, we want to change out the breather cap for a hybrid style breather. On that same fitting, we can also put a quick connect fitting so that we can add oil using our portable filtration equipment or decontaminate as necessary using our filter cart. On the drain port, we can use a drain port adapter that has a sight glass so that we don't have to use a dipstick to check the oil level, so we can easily and efficiently check the oil level without opening that system up and exposing it to contamination. In that same port, we have a sample valve with a pitot tube so we can take a high quality and very efficient oil sample. And we also have a quick connect fitting for removing oil, or again for circulating the oil using our filter cart. Likewise, we have the option of using another port and adding just a quick connect fitting if we simply want to use the portable filtration equipment. This is an example of a process pump. In this case, we want to remove the breather plug, replace it with a high quality breather. We want to remove the existing sight glass or level plug and replace that with a 3D bullseye. And then to one of the drain ports, we're going to install a BS&W inspection bowl so that we can inspect for gross water contamination and remove it as necessary. Now, as I indicated before, for larger systems like hydraulics, those may take a more customized approach. Not every compressor is the same, not every hydraulic system is the same, not every turbine system is the same, and usually we don't have a large number of different systems like that in a plant, so we can treat those individually if necessary. So when we look at a hydraulic system, again, we want to upgrade the breather. We want to get rid of the breather cap, replace that with a high quality desiccant breather. We want to add sample valves so that we can take oil samples, and we may want to add sample valves to multiple locations. We might want to have one on the return line, we might want to have one after the pump and before the filter, or we might want to have one where we can take samples directly from the reservoir, but without having to open the reservoir and drop a tube in. Or we might want to have all of the above. Each situation is different. And then we certainly want to have our quick connect fittings, so again we can use our filter cart to transfer oil and also to provide supplemental filtration if we need it. If the oil analysis indicates that we've had some type of contamination event, or if the filtration in the system just isn't adequate, we might want to add a permanent kidney loop filtration system so that we don't have to continuously keep coming back with our filter cart and decontaminating. Now, one of the other things that we have to consider with storage and handling is how we handle our inventory. How much inventory should you keep and how should you rotate that? There are a lot of questions and not a lot of good answers regarding the shelf life of most lubricants. But one thing we do know is that they don't last forever in storage. So lubricants can go bad sitting on the shelf. So to address this, a lot of people implement a policy of using the oldest container first, or first in, first out. But there's a really big problem with implementing that policy, and that is how most people store drums of oil, or 5-gallon pails of oil in most cases. So what most people do is stack drums one on top of the other, or pails one on top of the other, and then they stack them in a row against the wall, so that if we have a new drum of oil come in, it goes in the front. If we need a new drum of oil, say if we're filling a machine, we're usually going to take the drum that's right there in the front. So the only one that gets rotated is the first or possibly the second drum in that row. So we need to come up with a system that enables us to get to the oldest drum without having to remove everything else. Because of this situation, a lot of people end up having lubricant sitting in a storeroom for many, many years, even decades in some cases. So we need to store the drums in a way that allows the technicians to get to the old drum so that we don't have this problem of lubricants sitting around for years and years and years where they could possibly be compromised by the time we install them. And once you've gone through the entire process of addressing storage and handling, from the way that you receive oil, the way you store it, the way you dispense it, transport it, and apply it to the machines, it's very important to document all of those policies, to document the procedures for how you receive the oil and procedures for how you filter the oil before it's dispensed. There are a lot of different ways to do that. There's no one right way that really fits everybody, so most people come up with their own approach. However you do that, whatever that approach is, we need to document those so that this component of our program is sustainable. A lot of times people go through a lot of effort to fix the way they lubricate machines, but then over time they go right back to the way things used to be because of personnel changes, management changes, ownership changes, what have you. If we document all of our procedures, if we document how we store oil, how we apply the oil, how we sample it, etc., it makes the program sustainable so we can continue to build on that initial success. This is true for almost any aspect of lubrication, not just storage and handling. But I would strongly encourage you to create simple, they don't have to be very complex. They need to be simple procedures that just spell out the proper steps for handling new oil. This has been Lubricant Storage and Handling Best Practices Part 2. I'm Jared Pottinger, Education Services Manager for Deskcase.